Dear students, Namaskar. Hope you all are fine. Today we are going to discuss grade 10, subject mathematics, lesson 12, and here I have written circle 2 because today is the second class of circle. And today basically we deal relation between central angle and inscribed angle standing on the same arc. Dear students, in previous class also we discussed relation between central angle and inscribed angle standing on the same arc, and we proved there also that central angle is 2 times of inscribed angle standing on the same arc experimentally. Today we basically prove this theorem theoretically, but before that what we discussed in previous class, let us review. Central angle and inscribed angle. Okay, before to define central angle and inscribed angle, look at this figure. And question is, where is angle AOB formed? What is it called? Where is angle AOB formed? And what is it called? Yes, you are correct. Angle AOB is formed at the center O. So angle AOB is called central angle, and it is called central angle AOB. So look here, angle AOB is formed at center O of the circle. So angle AOB is called central angle, and arc AB is opposite to this central angle. Arc AB is opposite to this central angle AOB. So arc AB is called corresponding arc. Means an arc which is opposite to the central angle is called corresponding arc. Similarly, check this figure B, and again question is, where is angle PQR formed? What is it called? So where is angle PQR formed? Yes, you are correct. Angle PQR is formed at the circumference. And what is it called? It is called inscribed angle or angle at the circumference. Yes, you are correct. So angle PQR is formed at the circumference, and angle PQR is called inscribed angle or angle at the circumference, and arc PR is called opposite arc. Here you have to pay attention. An arc opposite to the central angle is called corresponding arc. It has a special name. Whereas an arc opposite to the inscribed angle is simply called opposite arc. So arc AB is corresponding arc of central angle AOB, whereas arc PR is opposite arc of angle PQR. Now again question is, what is difference between angle AOB and angle PQR? What is the difference? Compare. Yes, good try. Angle AOB is central angle. It is made by two radii OA and OB. Radii is the plural of radius at center O. Whereas angle PQR is called inscribed angle or angle at the circumference, made by two chords PQ and QR at the circumference of the circle. So what is the difference between angle AOB and angle PQR? Angle AOB is central angle made by two radii at the center, whereas angle PQR is inscribed angle made by two chords at the circumference of the circle. Now look this third figure. Question is, in figure C, that is in this figure, what arc APB, look here, this is arc APB, this is arc APB, what arc APB and arc AB called? Can you guess? Yes, good try. If the length of the arc is less than the semicircle, then it is called what? Minor arc. So here AB is the minor arc. If the length of the arc is more than the semicircle, it is called major arc. So APB is major arc. So what we can say, if an arc is smaller than a semicircle, it is called minor arc. So this arc AB is smaller than the semicircle, so it is called minor arc AB. If an arc is bigger than semicircle, or larger than semicircle, then it is called major arc. So arc APB is bigger than or larger than the semicircle, so it is called major arc. So in the figure, arc APB is major arc, whereas arc AB is minor arc. So on the basis of this much discussion, now can you define what is central angle? Yes, good try. So central angle, here you have seen, central angle is made by two radii at the center. So how can you define? The angle formed by two radii at the center is called central angle. One radius is OA, another radius is OB, the plural of radius is radii, so this is AOB is central angle. So what is central angle? Made by two radii at the center. Here angle AOB is central angle. Similarly, on the basis of this much discussion, can you define inscribed angle? Or inscribed angle is also called angle at the circumference. Yes, good try. Inscribed angle is an angle made at the circumference and made by two chords. So how can you define? The angle formed by joining two chords of a circle. Look here, PQ is one chord, QR is another chord. And by joining two chords of a circle at the circumference Q is called angle at the circumference or inscribed angle. In this figure, that is in figure B, angle PQR is inscribed angle or angle at the circumference. So what is the difference? Central angle is made by two radii at the center, whereas inscribed angle is made by two chords at the circumference. Now question is, what is the relation between central angle and inscribed angle standing on the same arc? In previous class, we have already proved experimentally that central angle is 2 times of the inscribed angle standing on the same arc. Here also, we are going to find the relation between central angle and inscribed angle standing on the same arc. So firstly, we draw a circle with center O. Take an arc AB of length anything. This is anywhere you can take point A, anywhere you can take point B. Now to get the central angle, with the help of ruler and pencil, join OA. Similarly, with the help of ruler and pencil, join OB. Now AOB is central angle. This AOB is central angle standing on the arc AB. Similarly, to get the inscribed angle standing on the same arc AB, now take anywhere point C. You can take point C here also, here also, here also, here also, here also, here also, anywhere. Except this arc AB portion, you can take point C anywhere. So we have taken point C. Now with the help of ruler and pencil, join AC, then join BC. Now here ACB is inscribed angle standing on the arc AB, whereas AOB is central angle standing on the arc AB. Now what is the relation between these two angles? We are going to find it. So we are going to describe the figure. O is the center of the circle, where AOB is central angle and ACB is a circumference angle, or you can say inscribed angle standing on the same arc AB. Now to find the relation between central angle and inscribed angle, we are going to join C and O. Right here, O and C are joined. And after joining O and C, this OA is radius of the circle, OB is also radius of the circle, and OC is also radius of the circle. And we know that radii of the same circle are equal. So what we can say? OA equals to OB equals to OC, because they are radii of the same circle. Now AOC is what type of triangle? Yes, you are correct. AOC is an isosceles triangle, because isosceles triangle means triangle in which two sides are equal. So in triangle AOC, OA and OC are equal due to radii of the same circle. So AOC is an isosceles triangle. Similarly, in triangle BOC also, OC and OB are radii of the same circle and they are equal. So BOC is also an isosceles triangle. And we know that base angles of an isosceles triangle are equal. What do you mean by base angles? Yes, you are correct. and angles that are opposite to equal sides are called base angles. So OC and OA are equal sides. Which angle is opposite to OC in triangle AOC? Angle OAC. Similarly, which angle is opposite to side OA in triangle AOC? Angle ACO, or you can say angle OCA. So which two angles are base angles? OAC and OCA are base angles. So what we can say in triangle OAC, OAC means this angle which is opposite to side OC, equals to angle OCA means this angle which is opposite to side OA, and OA and OC are equal sides, and angles opposite to equal sides are called base angles. So OAC and OCA are base angles of an isosceles triangle, they are equal. Again, in any triangle, sum of three angles is 180 degree. So in triangle AOC, if I add all three angles, then sum will be 180 degree. That is angle OAC, this is angle OCA, this is angle AOC equals to 180 degree, sum of angles of a triangle. We are finding the relation between central angle and inscribed angle. So OCA, this OCA is the part of inscribed angle, whereas AOC is the angle at the center. But this OAC is neither the part of central angle nor it is the part of inscribed angle. So we are going to put the value of angle OAC. Instead of angle OAC, what we can write from here? OCA. Then it becomes angle OCA. Instead of OAC, we have written OCA, because OAC is neither the part of central angle nor it is the part of inscribed angle. So OCA plus angle AOC equals to 180 degree. OCA plus OCA becomes 2 times angle OCA, and if I send angle AOC on right hand side, then it becomes 180 degree minus angle AOC. So what we can write? 2 times angle OCA, because angle OCA plus OCA is 2 times angle OCA, 180 degree minus angle AOC. So AOC is an isosceles triangle, and in triangle AOC, what relation we have got? 2 times angle OCA equals to 180 degree minus angle AOC. But BOC is same type of isosceles triangle. This BOC is also same type of isosceles triangle as we have discussed in isosceles triangle AOC. So if I do similar calculation in triangle BOC, then instead of this result, what result shall I get? Can you guess? Yes, you are correct. What result we get? 2 times angle OCB, this angle, equals to 180 degree minus angle BOC. So same we are going to write. 2 times angle OCB means this angle equals to 180 degree minus angle BOC. Now if I add this equation 1 and equation 2, then left hand side is added with left hand side and the right hand side is added with right hand side. So 2 times angle OCA plus 2 times angle OCB means 2 is common. Then what is left? Angle OCA plus angle OCB. Similarly, right hand side is added with right hand side, then 180 plus 180 becomes 360. And if I take minus common, then it becomes angle AOC plus angle BOC. Now look at the figure. Angle OCA, OCA means this angle, and angle OCB means this angle. So if you add this angle and this angle, it becomes angle ACB. So instead of angle OCA plus angle OCB equals to what we are going to write? Angle ACB. 2 times angle ACB, 360 degree as it is. Similarly, here if you add angle AOC means this angle BOC means this angle. If you add this angle and this angle, then it becomes angle AOB. But this angle is more than 180 degree. So what we can say it? Reflex angle AOB. So that's why AOC plus BOC equals to reflex angle AOB. Again, 360 degree is one complete rotation, and from 360 degree, if I subtract reflex angle AOB means this angle AOB, then what shall I get? Angle AOB. So what we can write? 2 times angle ACB equals to angle AOB. Here ACB is inscribed angle and AOB is what? Central angle. So what we have proved? 2 times of inscribed angle equals to central angle. So what is the relation between central angle and inscribed angle standing on the same arc? If central angle and inscribed angle both are standing on the same arc, then central angle AOB is 2 times of inscribed angle ACB, or you can say inscribed angle ACB is half of the central angle. So on the basis of this much discussion, what we can conclude now, thus the central angle is double, either you say double or you say twice, or you can say 2 times of inscribed angle standing on the same arc. We have already proved in previous class that central angle is 2 times of inscribed angle standing on the same arc experimentally. And today we are going to prove the same theorem, that is central angle is double of inscribed angle standing on the same arc theoretically. Okay, look here. So firstly we draw circle with center O. Now take an arc AB of length anything. So we have taken arc AB of any length. To get the central angle, join OA and OB. So firstly we have joined OA, then we have joined OB. Now AOB is central angle. Now to get the inscribed angle, on major arc AB, take anywhere point C. Major arc AB means this arc, anywhere point C on the circumference. We have taken point C here. Now join AC with the help of ruler and pencil. Similarly join BC also with the help of ruler and pencil. Then ACB is inscribed angle standing on arc AB. AOB is central angle standing on the arc AB. So here we have got central angle AOB and inscribed angle ACB, both are standing on the same arc AB. So we write the given, that we describe the figure. O is the center of the circle in which arc AB subtends means makes angle AOB at the center and angle ACB at the circumference of the circle. Now what we have to prove, central angle is double. Double means 2 times of inscribed angle. So central angle is AOB equals to 2 times angle ACB. But this figure is not sufficient to prove central angle AOB is 2 times of angle ACB. So we need to do construction. Construction is a type of plan. What plan will you do? What construction will you do? Think for a moment. Yes, you are correct. Firstly, we joined C and O. Then after joining C and O, when we join any 2 points, we get a straight line, and this straight line CO is produced to D. Question is, why we have done this type of construction? Firstly, we write the construction, then we discuss what we have done. C and O are joined, then this CO is produced to D. Why we have done this type of construction? After doing this type of construction, this AOC is a triangle, and in triangle AOC, side CO is produced to D. And you studied in previous class that when a side of a triangle is produced, we get an exterior angle. An exterior angle equals to sum of opposite two interior angles. That is, angle AOD equals to what we can write, angle OAC plus angle OCA. Similarly, this side also, for triangle BOC also, side CO is produced to D. So for triangle BOC, this BOD is exterior angle, and exterior angle equals to what we know, sum of opposite two interior angles. That is, we can write angle OBC plus angle OCB. In this way, we can express central angle in terms of inscribed angle. That's why we have done this type of construction. Now move to proof. Proof. We make the format like this: statements, reasons. After doing this construction, as we have discussed in previous slide, this OA, OB and OC are radii of the same circle. And we know that radii of the same circle are equal. So what we can write? OA equals to OB equals to OC. Why? Radii of the same circle. The plural of radius is radii. So after writing OA equals to OB equals to OC, now AOC is what type of triangle? AOC is what type of triangle? Yes, you are correct. AOC is an isosceles triangle because two sides OA and OC are equal. In any triangle, if two sides are equal, then that is called isosceles triangle. Similarly, BOC is also an isosceles triangle because two sides OC and OB are equal. So after doing this construction, triangle AOC is an isosceles triangle, triangle BOC is also an isosceles triangle. And we know that base angles of an isosceles triangle are equal. What do you mean by base angles? Angles that are opposite to equal sides. So OA and OC are equal sides. So which angle is opposite to side OC? Angle OAC. Similarly, which angle is opposite to side OA? Angle OCA. So angle OCA and angle OAC are base angles. So in triangle AOC, what we can say? Angle OAC equals to angle OCA. OAC means this, OCA means this. Why these two angles are equal? Because base angles of an isosceles triangle. We have already proved in one number, OA equals to OC. Then OAC and OCA are base angles of an isosceles triangle. Again, in same triangle AOC, in triangle AOC, side CO is produced to D. And we know that in any triangle, if any one side is produced, then we get an exterior angle. So AOD is an exterior angle. An exterior angle equals to what we know? Sum of opposite two interior angles. So angle AOD equals to what we can write? Angle OAC plus angle OCA. Look here. AOD equals to angle OAC plus angle OCA. Why? Because exterior angle is equals to sum of opposite two interior angles. So AOD is exterior angle and opposite interior angles are angle OAC and OCA. Okay? But we are finding the relation between central angle and inscribed angle. Look here, AOD is the part of central angle AOB. This AOD is the part of central angle AOB. OCA is the part of inscribed angle ACB. But what about this OAC? This OAC is neither the part of inscribed angle ACB nor this OAC is the part of central angle AOB, this OAC. So we need to replace this OAC because we don't need this OAC. So instead of OAC, what shall we write from 1? OCA. So what we can say in 3 number, AOD equals to, instead of OAC we can write OCA. So OCA plus OCA becomes 2 times angle OCA. So which two statements we have used here? 2, 1 and 2, 2. So what shall we write? From statements 2, 1 and 2. So in triangle AOC, side CO is produced to D, then AOD is an exterior angle and this exterior angle equals to, we have got 2 times angle OCA. BOC is same type of an isosceles triangle and in triangle BOC also side CO is produced to D. So if we do same type of calculation in triangle BOC as we have done in triangle AOC, then instead of this result, what result shall we get? Yes, you are correct. This BOD equals to 2 times of angle OCB. So we are writing here BOD equals to 2 times of angle OCB. We do not need to show it again. We do not need to do this much calculation again. We can write. Reason what? Similar as above facts and reasons. Means similar reasons, exactly same reasons as in 1. As we have done in 2 number calculation, if we do similar calculation in 3 number, we got this. Okay, now we are going to add 2, 3 and 3 number. Then what shall we get? How can you add these 2 statements? You know that when you have to add the statements, left hand side is added with left hand side and right hand side is added with right hand side. So add these 2 statements 2, 3 and 3 number. Then you will get angle AOD plus angle BOD. Look here, AOD plus BOD. And if you add the right hand side, then here is 2 times angle OCA, here is 2 times angle OCB, 2 is common. So angle OCA plus angle OCB. Reason, which 2 statements we have used here? Third of 2, then 3 number. So reason, adding statements 2 third, that is 3 of 2 and 3 number. Now look here again, AOD means this angle, BOD means this angle. So if I add this angle and this angle, which angle shall I get? Angle AOB. Similarly, on the right hand side, angle OCA, OCA means this angle, OCB means this angle. If I add this angle and this angle, which angle shall I get? Angle ACB. So, in 5 number, what we say? Angle AOD plus angle BOD. AOD means this, BOD means this. If I add these two angles, I get angle AOB. Similarly, OCA means this angle, OCB means this angle. If I add these two angles, I get angle ACB. So, 2 times of angle ACB. What is the reason here? So, in geometry, when we add 2 or more than 2 parts and we get the single part, then we call it whole parts axiom. So, whole part axiom we have applied in which number? 4 number. So, what we can write in reason? From 4 whole parts axiom. This proves the theorem. So, we have proved theoretically also central angle is 2 times of inscribed angle or double of inscribed angle standing on the same arc. Hope you have understood. Shall I move to the next theorem? Okay. What is the next theorem? Experimentally verify that angle in a semicircle is a right angle. You know, half of the circle is called semicircle and a right angle means 90 degree. So, an angle which lies in a semicircle is a 90 degree, that we have to prove. And you know that to prove any theorem experimentally, what instruction is written in SE examination? 2 circles of radii more than 3 centimeter are necessary. So, you have to draw 2 circles of radii more than 3 centimeter. And that 2 circles also you do not have to make equal. Why not equal? Because if you take same type of circle, if you make same type of figure, then it is obvious that result will be same. So, you have to make different types of figure to test whether this relation is true in every type of figure or not. So, we draw 2 circles of radii more than 3 centimeter. This is one circle with center O and this is another circle with center O of radii more than 3 centimeter. Now, to get the semicircle, how can you get the semicircle? Yes, you are correct. Diameter bisects the circle, or you can say diameter divides a circle into 2 semicircles. So, to get the semicircle, you need to draw diameter. So, firstly, I am drawing diameter AB in first circle. Similarly, diameter AB in second circle. Now, the portion above the diameter AB is one semicircle. The portion below the diameter AB is another semicircle. Similarly, here also in this figure also, the portion above the diameter AB is one semicircle and the portion below the diameter is another semicircle. Now, to get angle in a semicircle, so you may take angle in upper semicircle or in lower semicircle, it does not make any difference. But I am taking an angle in upper semicircle. So, on the circumference of upper semicircle, take anywhere point C. Suppose I have taken point C here, point C here, yes, on the circumference. Now, join AC and CB, join AC and CB. Then angle ACB is inscribed angle or angle at the circumference made by diameter AB. So, such angle is called angle in a semicircle. Angle in a semicircle means angle made by diameter at the circumference. This is angle in a semicircle. So, one angle we have taken in semicircle. Similarly, both figures we have to make different. So, take anywhere point C in the upper semicircle of second figure. Yes, I have taken point C here in middle. Now, join AC with the help of ruler and pencil. Join BC also with the help of ruler and pencil. So, this angle ACB is also in semicircle. What type of angle? What do you mean by angle in a semicircle? Angle made by diameter at the circumference is called angle in a semicircle. So, here angle ACB is in angle in a semicircle. Here also angle ACB is in semicircle. So, firstly, this is figure 1, this is figure 2. Firstly, we describe the figure. What we have done? We have drawn 2 circles of different radii, you have seen here. but the center of each circle is O. In each circle, AB is a diameter. Why we have taken diameter? Because diameter divides a circle into two semicircles. That's why to get angle in a semicircle, we must have to draw diameter. And in both figure, angle ACB is in the semicircle. Now what we have to verify then? Angle in a semicircle is a right angle. Right angle means you know an angle of 90 degree. That is angle ACB equals to what we need to verify? 90 degree. So to know whether angle ACB is a 90 degree or not, we have to measure angle ACB with the help of protractor. If it is 90 degree, then what we can say? Yes, angle ACB is 90 degree. If not, then we have to say no. So measure angle ACB with the help of protractor to get whether it is 90 degree or not. But before that, what we write here? Verification. Angle ACB we measure in both figures with the help of protractor and we tabulate its value. We make the table like this, figure, because we have written here figures because we have here two figures. Angle ACB, we have to measure angle ACB in both the figures, then we have to write the result. Now take out the protractor and measure angle ACB. Check here. What is the value of angle ACB in protractor? Look here. Exactly you have got how many degree? 90 degree. Angle ACB is exactly 90 degree. So write in table angle ACB is 90 degree. Result, angle ACB equals to 90 degree. Now measure in second figure also whether you are going to get angle ACB 90 degree or not. Measure angle ACB. Look here. In second figure also angle ACB is exactly how many degree? 90 degree. So write angle ACB equals to 90 degree. That is angle ACB equals to 90 degree in second figure also. So on the basis of this experiment, what we have learnt? What we have discussed? Angle in a semicircle is how many degree? 90 degree. 90 degree means what? Right angle. So on the basis of this experiment, what we write in the conclusion? Above experiment shows that the angle in a semicircle is a right angle, that is 90 degree. That is angle in any semicircle is how many degree? 90 degree. We have verified this theorem experimentally. Now we are going to verify same theorem theoretically. This is verified. Prove that the angle in a semicircle is a right angle. Yes, same. But this time we are going to prove this theorem theoretically. You know the meaning of semicircle? Half of the circle is called semicircle. Right angle means what? An angle of 90 degree. And we have discussed in previous slide, angle in a semicircle means angle made by diameter at the circumference. Or in other words, you can say inscribed angle made by diameter is called angle in a semicircle. So firstly, to prove this, firstly we draw a circle with center O. To get the semicircle, what we need? Yes, you are correct. We need diameter. So this is diameter AB. Yes. Then part of circle which lies above the diameter AB is one semicircle. Part of the circle which lies below the diameter is another semicircle. So we need to take any one semicircle, either upper semicircle or lower semicircle. I am going to take anywhere point C on the circumference of upper semicircle. This is point C. Now with the help of ruler and pencil, join AC. Similarly, join CB or BC. Then angle ACB is inscribed angle or angle at the circumference made by diameter AB. So this is called angle in a semicircle. ACB is angle in a semicircle. Now firstly we describe the figure. O is the center of the circle in which AB is a diameter. You can see why we have drawn diameter? To divide a circle into two semicircles. Then which angle is in semicircle? Angle ACB is in semicircle. Now what we have to prove? Angle in a semicircle is a right angle. Which angle is in semicircle? Angle ACB is in semicircle. So angle ACB equals to what we write? 90 degree. Yes. Okay, how can we prove this angle ACB is 90 degree theoretically? Is this figure sufficient or we need to do construction? Yes, you are correct. This figure is sufficient. We do not need to do the construction. So we write proof, statements, reasons. This is the format of proving any theorem theoretically. Okay, tell me, this AOB is central angle. This AOB is central angle standing on the arc AB. Similarly, this ACB is inscribed angle or angle at the circumference standing on the same arc AB. And we have already proved that if same arc subtends angle at the center and at the circumference, then central angle is 2 times of inscribed angle. That is, angle AOB is 2 times of angle ACB. Or you can say angle ACB, that is inscribed angle, is half of the central angle AOB. So can we write angle ACB, that is inscribed angle, is half of the central angle AOB? Yes. Why? Because we have proved in the theorem that central angle is double of inscribed angle standing on the same arc, or inscribed angle is half of the central angle standing on the same arc. So ACB is inscribed angle standing on the arc AB. Similarly, this AOB is central angle standing on the arc AB. So inscribed angle is half of the central angle. What is the reason? Inscribed angle is half of the central angle standing on the same arc. But we have to prove this ACB angle is 90 degree. How can you prove angle ACB is 90 degree? Yes, good try. AOB is an angle. But can you tell me AOB is what type of angle? Yes, since AOB is a straight line, so we can call it AOB is a straight angle. And what is the value of a straight angle? The value of a straight angle is 180 degree. The value of a straight angle is how many degree? 180 degree. So angle AOB is 180 degree. Yes. Reason? Angle AOB is a straight angle. Now if I combine these two statements, what happens in 3 number? ACB same, half same. Instead of angle AOB, what shall I substitute from 2? 180 degree. Same. Look here. We have substituted the value in 1 from 2. So ACB equals to half times, instead of angle AOB, what shall we write? 180 degree. So 180 degree divided by 2 becomes how many degree? 90 degree. So this shows that angle ACB, which is angle in a semicircle, is how many degree? 90 degree. So angle ACB equals to 90 degree. Which statements we have used? From statements 1 and 2. This completes the theorem, proved. Dear students, in today's class, we have learnt about central angle and its corresponding arc. Similarly, inscribed angle and its opposite arc. Similarly, we proved central angle is double of inscribed angle standing on the same arc theoretically. Similarly, we have proved experimentally as well as theoretically that angle in a semicircle is a right angle. Hope you have understood each and everything that we have discussed. See you soon in next class. Namaskar.